What's up? So today I'm building an oxygen and hydrogen generator. If you want to know how these things actually work, I'd suggest you go and watch someone like the organic chemistry tutor, because this is just going to be a build video. So go watch that and then come back to this. Alright, since none of you actually went and did that, I'm going to give you a quick rundown before I build the thing. So it's a lot more complicated than this, but basically neither hydrogen nor oxygen like hanging out alone in nature because they don't have enough electrons in their valence shell and they're unstable. So they basically form this disgusting electron sharing orgy in nature known as water. But they can also share electrons with each other, so hydrogen can be together and oxygen can also share with another oxygen. So instead of having water hang out like this, we're making them hang out like that. For this to really make sense, you really should watch a proper video on it. Like seriously, I'm just regurgitating information I found online. You should go straight to the source. Alright, so I started out with an old fuel filter that I found in a scrapyard, and then I gently fucked the shit out of it with an angle grinder. I then took all the filtery McFilter cardboard out of the inside and cleaned up all of the burrs. Next I was on the hunt for some graphite electrodes, because graphite resists corrosion and it's great at conducting electricity. So I chose to use second-hand pencils that were too short to really be used for anything else. So I passed a bunch of current through them until the surrounding wood gives up and releases its juicy graphite innards. Alright, so then I ended up sorting my piles of graphite rods from super dope, somewhat dope, barely usable, and actual doo-doo garbage. I then bought some new pencils to compensate for the shitty yield. I then got some dimensions for my electrodes and started modeling. I just wanted to mention one design consideration that I had while modeling up the fixture that holds all of the carbon rods. I need all of the rods to be as close together as possible, or at least the anodes and cathodes as close together as possible without actually touching each other. Because the more liquid is in between them, the higher the resistance, meaning I need higher voltage to be able to overcome that resistance. So ideally you want them as close as possible. Here I'm busy working on a part that goes in the roof of the hydrogen cell, so all the way in the top of the cylinder. I've modeled a big cone that will help capture gas on the hydrogen and oxygen gas outlet, and then on the sodium hydroxide inlet, I'm modeling an S shape similar to how toilets work to basically try and prevent gas from going out the inlet. Alright, so there are three reasons why I chose to 3D print this fixture out of ABS. Number one, its chemical resistance. Number two, its temperature resistance, because the hydrogen cell warms up with continued use. And number three, its availability. There are definitely better plastics to choose for this, but as far as things that I could actually get a hold of, ABS was a good option. The 3D printed fixture would have been pretty hard to print all in one piece, so I designed it as 3 separate parts and then acetone welded them together. Time to harvest the sweet fruits of laser cutting. Oh yeah, look at that shit. I can just pop these little bad boys out right there. Ho-ho, get out of there, bitch. Plate number 1 and plate number 2. As far as attaching the power to the electrodes, I am just wrapping copper wire around them a couple of times and then heat shrinking over that to Number one, prevent the copper from interacting chemically, and number two, to attach it properly to the electrode. Alright, we're just about ready for assembly here. I've got all the electrodes hooked up with their corresponding colored wires. I've got the 3D printed ABS fixture that goes inside the cell. I've got the laser cut discs for closing the lid along with its bolts that go with that. We've got the entire housing, the lid, and the fixture for gathering bubbles. Once I had evenly distributed the anodes and cathodes, I covered the sealing lip with a layer of silicone and then bolted the whole thing together. Alright, I've got the cell hooked up to a multi-tester set to resistance. So basically what I'm trying to do here is trying to determine whether or not the electrodes are touching each other without any electrolyte in there. There shouldn't be any connectivity between the two. And I haven't tested this before, so your genuine reaction right here. Basically, if it beeps like this, that's really bad. I have to take the whole thing apart. And if it doesn't, Bob's your uncle and we can go ahead. Here goes nothing. Sick! There's no connection! Sick! That's fucking sick, bro. I mean, I totally expected that. That is exactly what I thought would happen. Zero doubts at all. Alright, so I've hooked up a really professional test jig here. We've got a piece of MDF with a hole cut in it, some clamps holding it down. The cell is sitting here, hanging off of the edge right there. I've got this, which I use to fill it up with water and sodium hydroxide, and we've got it bubbling into here. And if we connect our power, you'll notice we're generating bubbles. For real, it's working.
It's working! It's working!
And if we go and turn that shit off and put a little bit of a flame to this bad boy, you'll notice a little bit of an explosion. Now that's fun and all, but it's not actually what I'm trying to achieve here. This is what I'm trying to achieve. A more contained, useful version of the combustion reaction. Okay, I'm not gonna lie to you guys, this is incredibly underwhelming. I wouldn't even blame you if you couldn't see it. It's that, ah shit, it just burnt me. It's that little teeny tiny flame coming off of the tip of this needle right here. Now, obviously we're gonna have to steroid this thing to be able to get it to run a lot more flow rate. You know what I'm saying? A smiley face engraved with a tiny blowtorch. So I know I just built this thing, but I can already think of a ton of cool improvements and upgrades, including like maybe mounting it to a CNC machine. I could see all kinds of cool, fun challenges with that. But I think for now, I'm just going to pack the thing away and deal with some other projects so that I can focus on it full-blown later on. Thanks for watching. See ya.